Welcome back, everyone. In our last video, we explored the fundamentals of machine learning. Now, we are taking a step further into the exciting world of deep learning. This is Chapter 2 of our PyTorch course, where we lay the groundwork for the powerful deep learning techniques we'll be implementing with PyTorch. Let's talk about deep learning. Deep learning represents a more specialized and powerful subset of machine learning. It's the technology behind many of the most impressive AI achievements in recent years, from beating world champions at Go to generating human-like text and creating photorealistic images. What is deep learning? Deep learning is a powerful subset of machine learning that's revolutionizing artificial intelligence. Let's break down what makes it special. It's a subset of machine learning, building on the foundations we discussed in our last video. Deep learning is based on artificial neural networks, which are inspired by the structure of the human brain. What sets it apart is its ability to learn hierarchical features automatically. This means it can discover important characteristics in data without human guidance. Because of this, deep learning excels at complex pattern recognition tasks, often outperforming traditional machine learning methods. At its core, deep learning teaches computers to learn from experience, understanding the world through a hierarchy of concepts. Each concept is defined in terms of its relation to simpler concepts, allowing the computer to learn very complex representations. Neural networks, the heart of deep learning. Deep learning is built on the foundation of neural networks. These are computing systems inspired by the biological neural networks that constitute animal brains. Input layer receives the initial data. Hidden layers process the information. Output layer produces the final result. The deep in deep learning refers to the number of layers through which the data is transformed. How neural networks learn. Neural networks learn through a process called backpropagation. Forward pass, data flows through the network. Error calculation, compare output with desired result. Backward pass, adjust weights to minimize error. Repeat, iterate this process many times. This process allows the network to automatically learn the most important features for solving the problem at hand. Types of neural networks. There are various types of neural networks, each suited for different tasks. Convolutional neural networks, CNNs excellent for image processing. Recurrent neural networks, RNNs great for sequential data like text or time series. Generative adversarial networks, GANs can generate new, synthetic data. Transformers, powerful for natural language processing tasks. Deep learning versus traditional machine learning. Let's compare deep learning with traditional machine learning. Feature extraction, automatic in deep learning, often manual in traditional ML. Data requirements, deep learning often needs more data. Hardware requirements, deep learning typically requires more computational power. Interpretability, deep learning models can be less interpretable. Performance on complex tasks, deep learning often outperforms traditional ML on complex tasks like image and speech recognition. Applications of deep learning. Deep learning has revolutionized many fields. Computer vision, object detection, facial recognition. Natural language processing, translation, sentiment analysis. Speech recognition, voice assistance, transcription services. Game playing, beating human champions at complex games. Healthcare, disease diagnosis, drug discovery. Autonomous vehicles, self-driving cars and drones. Key takeaways. As we wrap up, here are the key points to remember about deep learning. It's a subset of machine learning based on artificial neural networks. Deep learning models can automatically learn hierarchical features. It excels at complex tasks like image and speech recognition. Various types of neural networks exist for different problems. It has led to breakthroughs in many fields of AI. Understanding these concepts will be crucial as we start working with PyTorch in the coming chapters. We'll see how PyTorch makes it easy to build and train these powerful deep learning models. That's all for our introduction to deep learning. In the next video, we'll start getting hands-on with PyTorch, implementing some of the concepts we've discussed. Get ready to write your first neural network. Thanks for watching, and see you in the next one.